All right, I have everything together today, so we should be good to go. We should finish this up if there is weather tomorrow and we are at home, then you will probably have an Albert assignment. If we are not, if we're still in school, then we'll continue with our notes, okay? So if you're at home, you'll have an Albert assignment so that you can do it at any point in time. Otherwise, we'll do notes. All right, so statistical significance. The final step in performing a significance test is to draw a conclusion about the competing claims you were testing. We will make one of the two, should say decisions, based on the strength of evidence against the null hypothesis and in favor of the alternative. So this is what you're going to see, and don't let it confuse you too much, okay? We're either going to reject H sub O or fail to reject H sub O. Those are the only two conclusions that you're going to have, okay? Everything is based off of your null or H sub O. So when we look at this, if we reject H sub O, that means we go with our alternate hypothesis, okay? If we fail to reject it, that means our H sub O or our null hypothesis is the truth. All right, so if we went back and looked at this is just one page back, and we said, we found out that the mean was equal to 1,300, we would fail to reject H sub O. That means we're going to keep it. If we found out it was less than 1,300, so it was like 1,200, then we would reject H sub O in favor of H sub A. Okay, so those are the answers that you're going to give. Okay. So if our sample result is too unlikely to have happened by chance, assuming H sub O is true, then we'll reject H sub O and say that there is convincing evidence for our alternative or H sub A. Otherwise, we will fail to reject H sub O and say that there is not convincing evidence for H sub A. The wording may seem unusual at first, but it's consistent with what happens in a criminal trial once the jury has weighed the evidence against the null hypothesis of innocence. They return one of two verdicts: guilty. So that means they reject the null. Sorry, y'all. So guilty would be rejecting the null, or not guilty would be fail to reject. A not guilty verdict doesn't guarantee that the defendant is innocent, just that there's not convincing evidence of guilt. Likewise, a fail to reject H sub O decision in a significance test doesn't mean that H sub O is true. Oh my gosh. For that reason, you should never accept H sub O or use language implying that you believe H sub O is true. So drawing conclusions. In the free throw shooter example, because the estimated p-value of 0.0075 is so small, there is strong evidence against the null. And that null was, that your probability was equal to 0.80. For that reason, we would reject H sub O in favor of the alternative, which was that it was less than 80%. And this is exactly how we'd say it. We have convincing evidence that the virtual player makes fewer than 80% of free throws. For the Team Calcium study, however, the large p-value of 0.1404 gives weak evidence against H sub O, which was that mu was 1300. That's the one I just showed you a second ago. And in favor of the alternative, which said mu was less than 1300. We therefore fail to reject H sub O. Researchers do not have convincing evidence that teens are getting less than 1300 milligrams of calcium per day on average. All right, so they're talking about a lot of things here, and the big thing is the p-value. You're going to find that probability. You already know how to do that. You just don't realize that you do. You already know how to do that, and then you're going to compare it to your alpha, and we don't have alpha yet. We're about to learn what that is, and that will tell you whether you fail to reject or reject, okay? So we're not quite there as to why you do it, but they're just giving you background into what you say. Okay, so we're talking about language right now. We're not really talking about comparing and knowing. So in a nutshell, our conclusion in a significance test comes down to, I'm gonna go all the way to the edge of my paper. If your p-value is small, you're going to reject the null, and you're going to say that there's convincing evidence for the alternative, and then in context. Then if the p-value is large, and again, we'll get to all of this if you're like, oh my God, what's the p-value? What's the p-value? It's just a probability, okay? And again, you already know how to do it. We just haven't done a problem where you found it yet. You have, it was just in previous chapters, okay? So we'll get there. So we'll talk about that p-value soon. If it's large, you're gonna fail to reject H sub O. Not convincing evidence for the alternative, and then put it in context. So again, here's what's going to happen. You're going to find that probability, okay? Again, already know how to do that. You're going to find it. You're going to compare it to some alpha level. That's what we're going to talk about in just a minute. If it is less than an alpha, then you're going to do one thing. If it's greater than the alpha, you're going to do the other. Okay, so if it's a small p-value, we're going to reject. If it's a large p-value, we're going to fail to reject. And we'll get to that in just a minute. And again, p-value is the probability of it happening. So there's no rule as to how small a p-value is required to reject H sub O. It's a matter of judgment and depends on the specific circumstances. But we can compare the p-value. Flip it over in just a second. We can compare the p-value with a fixed value. We regard it as decisive, called the significance level. This is the alpha that I keep referring to. We write it as alpha, the Greek letter. Your most typical alpha is 0.05. So we'll compare that percent to 0.05. Are there other ones? Absolutely. This is the most typical, this and 0.10 is typical in stats. We are requiring that the data give evidence against H sub O so strong that it would happen less than 5% of the time, just by chance. When H sub O is true. So in chapter 4, we said that an observed result is statistically significant if it would rarely occur by chance alone. When our p-value is less than the chosen alpha in a significance test, we say that the result is statistically significant at level alpha. And that's right below it in that box. Okay, so the definition of that, if the p-value is smaller than alpha, and we're going to summarize this again. If the p-value is smaller than alpha, we say that the results of the study are statistically significant at level alpha. I just don't want to write it all, and I don't want you to have to write it all. In that case, we reject the null or H sub O and conclude that there is convincing evidence in favor of the alternative hypothesis H sub A. Significant in the statistical sense does not necessarily mean important. It means simply not likely to happen just by chance. The significance level alpha makes not likely more exact. So we don't know what probability is important and which one is not until we compare it to that alpha, okay? So significance level at 0.01 is often expressed by the statement, the results were significant. That would mean that the p-value was less than 0.01. So here P stands for the p-value. The actual p-value is more informative than the statement of significance. because it allows us to assess significance. And again, I don't care if you abbreviate like I am, at any level we choose. For example, a result with P equal to 0.03 is significant at the alpha equals 0.05 level, but is not significant at the alpha equals 0.01 level. When we use a fixed significance level to draw a conclusion in a statistical test, this is what's going to happen. So this is basically the same thing that we had just a second ago. So it's the same little chart that I wrote out, or whatever, the little flow chart. If the p-value is less than alpha, so right here we have 0.03 was less than 0.05. We said it is significant. So that means we would reject H sub O. That would be convincing evidence for the alternative, and then make sure that you put it in context. So this is the important part right here. So if the p-value is less than alpha, we reject H sub O. If the p-value is greater than alpha, so it says it's not significant, so 0.03 was greater than 0.01, which was our alpha here. Then we fail to reject. It is not significant, so it doesn't change our null. So there is not convincing evidence for the alternative in context. And that's exactly how you're going to say your answers or your conclusions. So if it's greater than alpha, fail to reject H sub O. You need to know that. Again, for the rest of the notes, there's not a lot going on. It's just fill in the blank and understanding how to write this. Okay. So for example, statistical significance, a company has developed a new deluxe AAA battery that is supposed to last longer than the regular AAA battery. However, these new batteries are more expensive to produce. So the company would like to be convinced that they really do last longer based on years of experience. The company knows that its regular batteries last for 30 hours. The company selects an SRF of 15 new batteries and uses them continuously until they are completely drained. The sample mean lifetime is X bar equals 33.9 hours. A significance test is performed using the hypothesis. What is our null hypothesis going to be? Not we don't use our sample. What do we use? 30. Very good. Perfect. So then what would our alternate be? Okay. What did we say about the new batteries? That they're better. So it's got to be greater than. Perfect. So it did justify which side. Now, that's if you had to write those, they actually gave you those this time. Where mu is the true mean lifetime of the new deluxe AAA batteries, the resulting p-value is 0.729. We'll learn how to find a p-value. They're giving it to you right now, okay? So don't stress out. You already know how to do it. Okay. So what conclusion would you make for each of the following significance levels and justify your answer? So if we go back to that chart, we're doing our p-value compared to alpha. So this is A. Our p-value was 0.0729. Our alpha for the first one is 0.10. You put a comparison symbol in there. Is it greater than or less than? It said on the other one, if it's less than, we reject H sub O, which means we have convincing evidence that the companies probably should have put deluxe in there, AAA batteries, the new ones. Do what? If we rejected H sub O, that means that didn't work and we went to this. So what does this tell us? What was this? So they last longer than 30, right? Or last longer than the other batteries. So the new AAA batteries last longer than 30 hours. On average. And on average covers the word mean. Okay, so somewhere in there you need to make sure the mean battery life, anything like that would be fine. The mean battery life is greater than 30. All right, but what if we test it, the p-value of 0.0729 against the alpha of 0.05? What if we test it that way? What comparison symbol am I going to use? How does 0.07 compare to 0.05? It's greater than. So that means we failed to reject. It is the same sentence, except for we do not have convincing evidence. Got it? It is the same exact thing. Again, same sentence. If you need to write that on your notes, same sentence, just the words do not happen. Okay, so again, fail to reject, do not have convincing evidence, reject, we have convincing evidence. All right, flipping it over. In practice, the most common used sig level or significance level, I told you, was the 0.05. That's typically what you're going to see. This is mainly due to Sir Ronald A. Fisher, a famous statistician. Who worked on agricultural, I cannot talk today, experiments in England during the early 20th century. Fisher was the first to suggest deliberately using random assignment in an experiment. In a paper published in 1926, Fisher wrote that it is convenient to draw the line at about a level at which we can say either there is something in the treatment or a coincidence. Has occurred, such as does not occur more than once in 20 trials. So 1 out of 20 is 0.05. Sometimes it may be preferable to choose alpha equals 0.01 or even alpha equals 0.10 for reasons we will discuss shortly. Warning, if you're going to draw a conclusion based on a sig level alpha, then alpha should be stated before the data are produced. So that when we start doing state plan do conclude, it has to come at the top. Okay, and that is in the state. I always put it in the state part. Otherwise, a deceptive user of statistics might set an alpha level after the data has been analyzed in an attempt to manipulate the conclusion. This is just as inappropriate as choosing an alternative hypothesis to be one-sided in a particular direction after looking at the data. All right, so how do you choose a significance level? The purpose of a SIG test is to give a clear statement of the strength of evidence provided by the data that's against the null and in favor of the alternative hypothesis. The p-value does this. But how small a p-value is convincing evidence against the null hypothesis? This depends mainly on two circumstances. The first one is, how plausible is H sub O? If H sub O represents an assumption that the people you must convince have believed for years, then strong evidence, which is a very small p-value, will be needed to persuade them. So if you are trying to prove that chemo did not help cancer, people know now that chemo does, but it would take a lot for you to convince them otherwise. That's all it's saying, okay? And then the second one, what are the consequences of rejecting H sub O? If rejecting H sub O in favor of H sub A means making an expensive change of some kind, you need strong evidence that the change will be beneficial. So in the case of the batteries, it costs more to produce them, so companies are not going to want to produce them because they're spending more money to produce them. So they'd have to have really good convincing evidence to show that more people would buy their product. Okay. So these criteria are a bit subjective. Different people will insist on different levels of significance. You gonna make it? Girl, I mess up all day long. You be good. Giving the p-value allows each of us to decide individually if the evidence is sufficiently strong. Users of statistics have often, good gracious, emphasized standard significance levels, such as 10%, 5%, and 1%. Those are the only three that we pretty much use in here. Will there be other ones? Possibly, but that's the main one. The 5% level, where alpha is equal to 0.05, is very common. For example, courts have tended to accept 5% as a standard in discrimination cases. Beginning users of statistical tests generally find it easier to compare p-value to a significance level than to interpret the p-value correctly in context. For that reason, we will include stating again, we're going to include stating a significance level. I'm about to turn the page the right way. As a required part of every significance test. Okay, so again, that's in that state plan do conclude, you have to state your alpha level, and it will change throughout the problems, but the most common one is a 0.05. We'll also ask you to explain what a p-value means in a variety of settings. All right, so type 1 and type 2 errors. When we draw a conclusion from a significance test, we hope our conclusion will be correct. But sometimes it will be wrong. There are two types of mistakes we can make. We can reject the null hypothesis when it's actually true, known as a type 1. Or we can fail to reject H sub O. When the alternative hypothesis is true, which is a type 2 error. You need to know the difference between the two. Okay. So if we reject H sub O when H sub O is true, we have committed a type 1 error. So we won't have class tomorrow. We're not gonna be in school. All right. Yep. That's what it said. As far as I know, due to the weather forecast for February 18th, Thursday will be an annual leave day. That means I don't work. It's not a remote instruction day due to the threat of ice and power outages. DCS feels it is the best option for everyone. So, I don't think so. Just keep listening for it. We usually get it ahead of you guys, so just keep listening. What? Yeah. All right, if we fail to reject H sub O when H sub A is true, we have committed a type 2. All right, the possibilities are summarized in the following figure. I can't spell. If H sub O is true, our conclusion is correct. If we fail to reject H sub O, that it is a type 1 if we reject H sub O. So this is just repeating everything that we just said. If H sub A is true, our conclusion is correct. If we reject H sub O, that is a type 2 if we fail to reject. Only one error is possible at one time. And then it just gives you a little chart. So if you say that H sub O is wrong, but it's actually true, that's the type 1 error. Okay, so that's exactly how you read the chart. It's the same thing over and over again. It's important to be able to describe type 1 and type 2 errors. In the context of the problem. And this is really simple. It's not hard at all. Considering the consequences of these types of errors is also important, which you will always do, as the following example shows. And again, they're really simple. What's hard is remembering which one is which, okay? We're getting there, y'all. We're getting there. All right. So potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away. We've already seen this problem before. Otherwise, the entire truckload will be used to make potato chips. To make a decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will then, perform a SIG test using the hypotheses. Here are the two. We want our proportion to be 8%. We send them away when it's greater than 8. Where P is the actual proportion of potatoes with blemishes in a given truckload. Describe a type 1 and type 2 error. So type 1 means that we reject H sub O when it's actually true. Okay. So that means we say that there's more than 8% of the potatoes that are blemished. Okay, so we reject it. That means we cut it out. We don't have it anymore. So we're using the alternative. So we say more than 8% blemished. But if it's a type 1, that means that actually 8% or less are. So let me ask you this, what's the problem with that? In the context of the problem, what's the problem with that? What potatoes did they send away? Yeah, the ones that were good, right? So they wasted good potatoes. So that's why it's important to understand the type of errors. Okay, so if you have that error, that could cost a lot of money. Type 2 means that we fail to reject H sub O when H sub A is actually true. So that means if we fail to reject H sub O, then we're keeping H sub O. So that means we would say the potatoes aren't blemished when what? They actually are. What's that going to cause? Why? They don't want ugly potato chips. Y'all eat the dark brown ones? No. Yeah. Well, that's what they make them out of. Is they're making the potato chips out of those potatoes. So they don't want ugly potatoes and have nasty looking potato chips. All right. So then on the next one, check your understanding, refer to the better batteries, and remember the better batteries are H sub O was that our mean was 30 and H sub A was that our mean was greater than, 30, greater than 30. So we talked about the crappy batteries versus the new deluxe batteries that were more than 30. So describe a type 1 error. Remember, type 1 is reject H sub O when H sub O is actually true. So if we reject H sub O, that means we kind of mark it out and we're looking at the other one. So we say that the battery life is greater than 30 when it's actually not. And then eventually you're going to have to tell a problem with this. So the customers are going to get mad if you advertise that the batteries are, but they're actually not. And we'll get to that in a minute. Type 2 is we fail to reject H sub O when H sub A is true. So that means we keep the null. So type 2 is going with the null. So we say they're equal to 30 when actually greater than 30. So which one is going to be more serious?
Type 1,
Why?
because it's like you're giving false information rather than just like not giving true, if that makes
Yes,
sense.
yes, yes, yes. So you're going to have angry customers. No, it could change. It could change. Yeah. So they would be mad about, I mean, they wouldn't be mad. It would be false advertisement on this part if we had a type 2 error. So that's still wrong. But if I'm buying a battery and I get more than 30 out of it, am I going to complain? No. So that one's not as bad as the other one. All right. If we look at the bottom, we're almost done. Error probabilities. We can assess the performance of a significance test by looking at the probability of the two types of errors. That's because statistical inference is based on asking. What would happen if I replaced the data production process many times? We cannot, without inspecting the whole truckload, guarantee that good shipments of potatoes will never be sent away and bad shipments will never be used. But we can think about our chances of making each of these mistakes. For the truckload of potatoes in the previous example, we were testing. Oh, sorry. That the probability is 0.08 against the alternative that the probability was greater than 0.08. Where P is the proportion of all potatoes with blemishes in the shipment. Suppose that the potato chip producer decided to carry out this test based on a random sample of 500 potatoes using a 5% significance level, which means that alpha is 0.05. The type 1 error is to reject H sub O. Again, we just already know this. When it's actually true. If our sample results in a value of P hat that is much larger than 0.08, we will reject H sub O. So this is this 0.08 rejecting it compared to the alpha level. So whatever we decide compared to the p-value. So how large would p hat need to be? The 5% significance level tells us to count results. That could happen less than 5% of the time. By chance, if H sub O is true, as evidence that H sub O is false. So this is probably not making sense, but it's going to happen right here. So assuming that H sub O or our null is true, the sampling distribution of p hat will have an approximately normal shape. Remember, the mean of p hat is just your probability. If we have proportions, our standard deviation is p hat 1 minus p hat over n. All of that is in the problem. So 0.08, 0.92, and our n was 500. We said that in the beginning. So the following figure shows the normal curve that approximates this sampling distribution. All right, so this next paragraph is going to describe the curve. Go ahead. I was waiting on you. Yeah, I told them. I'm gonna still take my stuff though. Yeah, they'll get it. They'll get it. Again, this last paragraph is just describing this top part, the shaded area in the right tail. And I don't know if you guys can see that it's shaded. It's this part. It's 0.05 or 5%. We use the calculator command. Inverse norm, 0.95, 0.08, 0.01213. So the area, the proportion, and the standard deviation, or the mean, the standard deviation. To get the boundary, value of p hat equal to 0.10. Values of p hat to the right of the vertical line at p hat equals 0.10 will cause us to reject H sub O, even though H sub O is true. This will happen in 5% of all possible samples. That is the probability of making a type 1 error. So that 0.05. All right, we're going to do this last paragraph above. Yep. Yep. Are y'all still playing tonight? Okay. Sorry, y'all. The probability of a type 1 error is the probability of rejecting H sub O when it is true. As the previous example showed, this is exactly the significance level of the test. So I don't care about all this down here. Your alpha is the probability of a type 1 error. That's what you need to get out of that. All right, so I did post your homework